Okay, so we're going to start here with finding intercepts. So on a graph, to find the intercepts, you're just going to look at the places where you cross the axes. So see how this is the u-axis, and we cross it at 20. So that means the u-intercept is 20, 0. Because you would go over 20 and then not up or down at all. So that's why your y value is 0. And then your f of u-intercept is right there at 0, -8. You didn't go left or right at all, down 8. So 0, -8. And then to find intercepts given an equation, you're going to say, okay, well, if I want the c-intercept, then I make this 0. So in this case, that's h of c. So whenever you're looking for your x-intercept, you make y 0. So here I would say 0 equals 4c minus 15. And then I solve for c. So I'll add the 15 to both sides. And then I'll divide both sides by 4. And they're going to always want you to write this as a point. So I would put this in as 15 over 4, 0. And then for my h of c intercept, I'm going to set c equal to 0. So I want to know when c is 0, what is h of c? And here, 4 times 0 is 0. So you would just get h of c is -15. And so as a point, you would say, okay, well, c was 0 when h of c was -15. Okay. Next. All right, so here we're looking for a local max and a local min. So I know that Andy does a lot of explanation in his video, but just a reminder that a local max is a turning point like this. We definitely can tell it's a maximum because it's at the top of this curve. So this would be a local max. And then that point looks like it would be -1.5 and about 2.2. And a quick note that more is pretty forgiving here. So like if I put 2.1, it would probably still give me credit. It has like an acceptable zone when your points are not exactly on lattice points, okay? So to put that in down here, you would say it has a maximum of, and this is going to be your y value. So of 2.2 that occurs at, and then whatever this letter is right here, you're going to use, so w equals, and then your x value. Okay, so that letter is going to be important because you're going to have to put that letter, whatever this is, equals, and then whatever the x value of your min or max is. So this would be a local min, and that point looks like it is at about 1.5, -2.2. So when I put that in here, I would say a local min of -2.2 that occurs at w equals 1.5.
I had a question on that real quick before you move on.
Yeah, what's up?
So I know initially when you started the equation as far as finding your well either one local maximum or local min when you put it in your calculator, when you're going uh first finding your left side and then doing your right side and
We're
then
gonna do a
checking
calculator
out.
example. This is not a calculator example.
Oh, okay. All right. Thank you.
Let me get there. I promise. Look, it's there. I'm gonna go through a whole walkthrough for you. Okay. But I didn't do the calculator for that one because you don't need it. All right, so then here, I want to know when is this increasing, decreasing, and constant. So the function is increasing if from left to right it's going up. If as x goes up, y goes up. So this section of the graph is increasing. And now a note that your intervals for these should always have x values. They should have, your first one should be your x start value, and then you should have an x stop value, and this should be on the left, and this should be on the right of that interval. And these will also always be parentheses, never brackets. Okay? So I know I mentioned last time about arrowheads. There's no, it doesn't say that it stops here, so I'm going to assume that it keeps on going, which means that it would be increasing forever this way. It's always going to be increasing, so we would say that it always increases, and then it stops increasing at -2. Because again, I only want x values on these intervals. And so then the next section of the graph is going down. So that's decreasing. So from left to right, if it's going down, then it's decreasing. And here we would say it starts decreasing at that maximum and stops decreasing at this minimum, which looks like it has an x value of about 1.5. And so the next section of the graph looks like it's increasing again. So we're going to use the u anytime you have more than one interval. And so this one starts increasing at that 1.5 minimum and keeps increasing forever. So then next up is end behavior. And so end behavior is exactly what it sounds like. It's the behavior at the ends. So they're asking me for the right hand first. So this would be my right end. And so on the right, as W goes to the right, what's happening to your Y? Well, it's going down. So this is as W goes to the right, P of W goes down, right? This arrow is pointing to the right and down. And now a note that whatever letter is this is, it goes here, and whatever function notation this is, it goes here. Okay, and so then this is also as W, but now we want to know left. So as W goes left, P of W, well, that arrow is pointing left and up, so P of W goes up. Okay, so these are asking left and right, these are asking up and down. All right, now we're going to talk about the calculator. So before I pick up the calculator, I want to make a note that you don't need the calculator to find the h of r intercept. In standard form, we just said that to find the h of r intercept, we would make r 0. So if r was 0, that means this would be 0, this would be 0, and this would be 0. And the only thing that would be left is my constant. So this first one is always 0 and whatever your constant number is. Okay? Now, I already have this equation in my calculator because I just did this with my class before you. So I just want to show it to you in there. So there it is. And then you see how this says negative 15, 15. So to change this, you're going to press the window button. And then this is your x min, and this is your x max. So I'm going to change x min to negative 15. I'm going to change x max to 15, and then I'm going to graph it. Now, I am still not super happy with this graph because those lines are so steep that I have a hard time telling which ones of them are increasing and which ones of them are decreasing. So at this point, I'm honestly just going to play around with my y-axis until I get something that I feel like I'm comfortable with. So I'm going to press window, and then let's zoom way out. So let's make my y min negative 100 and my y max positive 100. And now the scale here, that's how often it's going to put those tick marks. So let's change that to 10 so that we don't have 100 little tick marks, or 200, I should say. Well, that's way better. I think I'm going to zoom down just a little bit more. And again, this is totally like me just playing around with the numbers. Oop, that's not what I wanted. I wanted y min of negative 500, y max of positive 100 still. That's better. I should have changed my scale though. All right, I feel like I have a better idea of the shape of this graph now. And so I can see that even though I can't see it, I know there must be a minimum down here somewhere because it has to turn around, right? And I can see that this is decreasing, this is increasing, this is decreasing. So I think I'm just going to stick right here. Okay. And now let's use the calculator to find those intercepts. So to find the intercepts, you're going to go to calc, which is right here. To get to it, you press second and then trace. So second and trace to get to calc. And then make a note for yourself that the intercepts are the zeros. So we're going to go to 0 and then press enter. Now it's asking me left bound. So what that means is I'm going to move the cursor to the left of the intercept. So if I'm looking for this intercept right here, I need the cursor to be somewhere to the left of that intercept. It doesn't matter how far to the left, just anywhere to the left. So right there is good, and then I press enter. And now for the right bound, I move my cursor so that it is anywhere to the right of that intercept. It doesn't matter how far to the right, just anywhere to the right, and then press enter. And I know in his video that Andy says that he finds guess helpful, but I do not, so I always just press enter and go right past it. And so there's my 0. 9, 6, 4. Okay, let's try it again. So we're going to do second and then trace to get to calc, then 0. And now let's find this middle 0. So I need to move my cursor so that it is to the left of that 0. Anywhere to the left is fine. How about right there? So then here's the cursor anywhere to the right of that 0. That's fine. And then press enter to get past guess. And so my second 0.03, I want 3 decimal places, right? Yeah. 0.035. Okay, one more time for my last 0. So we're going to press second and then trace to get to calc again. And then we want a 0 again. And now we want to be, if I'm looking for that 0 right there, I want to be anywhere to the left of it. So this is fine. Then anywhere to the right of it. And then enter one more time to get past guess. And so that 0 is at 2.714. So we're going to use the calculator again, this time to find the local minimum, which we know is down here somewhere. So press second and then trace to get back to calc, and we're going to look for a minimum. So for left bound, again, we got to move that cursor so that it's to the left of that minimum. And I know the minimum is down here somewhere, so that's to the left. So press enter. Move it so that it's to the right. That's to the right since it's down here somewhere, and press enter. Enter one more time past guess. Negative 7.6. Negative 1362.062. And so when we put that in more, we're going to say that it is a local minimum of negative 1362.02. That occurs at, what was my letter? R. R equals negative 7.6. All right, last but not least, let's find this maximum right here. So I'm going to press second and then trace to get to calc. This time I'll go down to maximum and press enter. Over to the left, there we go, press enter. There's my maximum, so anywhere to the right of it and press enter. Enter one more time. So that maximum is at 1.41. If I'm rounding to 3 decimal places, that would be 100.804. So a local maximum of 100.804 at R equals 1.41. Okay, so if we're looking for increasing, decreasing constant, this first section of the graph is decreasing. So let's start there. I'm going to say it starts decreasing at negative infinity, and then it would stop decreasing at that minimum. And I know where the minimum is. The minimum is at negative 7.6. Then the next section of the graph is increasing, and it would start increasing at that minimum. And it keeps increasing until it gets to this maximum, which is at 1.41. And then the next section of the graph is decreasing. It starts decreasing at 1.41, and it will continue decreasing forever. So a note that the only numbers you should have over here, you should definitely have infinity signs, but the only numbers you should have over here should be these numbers right here. Okay, your x values for your maximum minimum should be the only numbers that you have over here. Did I answer your question about the calculator? I forget who said that before. Who was asking you about the calculator before? Nobody, I imagined it. Okay, cool. So the next piece of this section is on average rate of change. So keep in mind that average rate of change is just a fancy way of asking for slope. And when you're given average rate of change, remember that slope is y2 minus y1 over x2 minus x1, right? Well, this is my x1 and this is my x2. So the two numbers that they give you are always x1 and x2. And in order to get y1 and y2, you're going to have to plug those in. So if they give you a table, you're going to use the table. If they give you an equation, you're going to use the equation. But whatever they give you, this is x1, get y1. This is x2, get y2. So we'll say 9 times negative 8 squared minus 6 times negative 8 plus 6. So my first point is negative 8, 630. So that's x1, y1. 9 times 2 squared minus 6 times 2. My second point is 230, so that's x2, y2. So then my slope would be 30 minus 630 over 2 minus negative 8. So 30 minus 630 is going to be a negative 600. 2 minus negative 8 is 2 plus 8, so that's 10. So then this is going to reduce to negative 60. And then last but not least for this set of notes, I clearly did not give myself enough room to do this difference quotient project or problem. So let me grab a piece of paper. I almost just lost everything on my desk. It almost just all came tumbling down. That would have been bad. Okay, now let's find a piece of paper in this notebook that my daughter did not draw all over. Okay, I'm definitely going to have to get a new notebook. Here we go. So I'm going to write my function down for myself. Q of u equals 2 plus 8u squared. And so I'm going to do the difference quotient with this. So the difference quotient here would be q times u plus h minus q times u over h. So q of u plus h would be 2 plus 8 times u plus h squared. And then I want to subtract from that q of u, which is just this. Okay, so over here on this side, I'm going to do u plus h squared, which is going to be u plus h times u plus h. That's going to be u squared plus uh plus plus h squared, which will be u squared plus 2uh plus h squared. Okay, so when I square this, I get this. So let's replace it. U squared 2uh h squared. And then from that, we would like to subtract 2 plus 8u squared. And we put the whole thing over h. Okay, now let's distribute. So we'll distribute this 8 through. 8u squared, 16uh, 8h squared. And then let's also distribute this negative. So that's going to be a -2 and a minus 8u squared. Now, if we look, we can see that a couple things cancel here. 2 minus 2 would cancel. A plus 8u squared and a minus 8u squared would cancel. And I would be left with 16uh plus 8h squared. And now at this point, I'm going to try to cancel this h on the bottom. And to do so, I'm going to GCF an h out of everything in the top. So if I divide an h out, I would be left with 16u. And if I divide an h out, I would be left with 8h. And we do that specifically to be able to cancel that h right there. So you should always be able to cancel your h in the denominator. If you cannot cancel that h, then I would go back and check your math because you definitely messed something up. And so my difference quotient here would be 16u plus 8h.